Hey guys, Justin here. We're going to do our part 2 tutorial. More of a discussion maybe than a tutorial. This is part 2 on making a stacked PCB board design in EasyEDA geared towards Eurorack design. So for this example, we were talking about using the Buchla. The Buchla low pass gate was the example that we're using for this. So we left off, we had created the two schematic symbols. One was for the 3-pole double throw switch, and then the other one was for the interesting 5-lead Vactrol that you need to make this module. So this is the completed schematic. We're going to jump ahead. There's nothing else about this schematic that is distinctive really. Anything that's challenging besides creating those footprints. The one component you probably don't have in your box of electronic parts is this diode, the 1N5228 Zener diode with a specific voltage. And then the only other thing that I did was I used a header here. This is for the resonance circuit, and this header means that you can put a jumper across here if you want to skip this circuit, or you can jump from 1 to 3 and from 2 to 4 in order to add the resonance into your circuit. So where do we go from here? We've got our schematic designed and put into EasyEDA, but now we need to create a 2-layer printed circuit board. So typically we're going to have one board that's going to be our control board, right, with all the pots and switches. And then we're going to have another board that's kind of what I call the master board that has all the chips on it and everything. So there's two strategies you can use that I know of. I'm sure there might be more, but there's two that I've come up with that you can use to create this, change this into a 2 printed circuit board design. One option is to put everything onto one printed circuit board and then do what's called panelizing, where you split it into 2, and the PCB factory will, you've seen it before where they drill a whole bunch of holes or slots and you can just snap the 2 printed circuit boards apart. And in this case they're going to route a V groove down between the 2 circuit boards, and then you can snap those apart to their final dimensions. The other strategy that I'm going to show you is, I think, maybe a little easier. The way I do it is I split it into 2 printed circuit boards. So I take the project, I clone it twice. Once will be the control board and the second one will be the master board. And then once I do that, I just delete out all the components on either schematic to have what's left that's going to be on that board. Now there's advantages and disadvantages to both. One of the disadvantages to doing it on one board is you're going to end up with the rough edges when you snap the PCB apart. It may bother you, it may not. The advantage to that is it's going to be a little cheaper, right? Because you've only got it's one board, so it will be a little bit cheaper than 2 separate boards. And it is a little more complicated to think about, I think, when we do it. But let me go show you a couple projects here that I can use it as an example. So this is the Electric Druid schematic 13700 LM13700 VCA. I've put it into EasyEDA here. I've got everything on here. This is a complete schematic, and then I cloned it twice. I've got the main board here and a control board here. So the way you can clone a project is you just right click on it and you choose clone, and then you can rename it. It'll make a complete copy of your project. If we go into let's look at the control board schematic. So you'll see here that I've got all the pots and the input jacks and the output jacks, and I added these in. Okay, these are 2 headers. This is a 6-pin header and another 6-pin header. These are going to be what join the 2 printed circuit boards together. So I've got a top one and a bottom one. Then I use net labels like we've used before. So you've got, for example, offset 1 goes right here to offset 1, and it goes into pin number 2. So what this means is you have to create, you have to make a match. So if we look at our master schematic, you'll see that I've got the exact same header here. Now you can do it on one of them and then just copy it over. And then if you look, the offset 1 here goes into this net label. So this one's going to go to pin 2 on the top header, and then it will go from pin 2 on the top header into this pot, right? So that's how we can split this project into 2 separate printed circuit boards. Now, you'll notice that I've got the ground and the plus 12 volts going from the master board up to the top board, because this pot needed 12 volts, and of course so did this offset 2. Oh, I see. Yeah, so I made it into two sets of VCAs. There's 2 VCAs on this board, so that's why I've got offset 1 and then offset 2. So that's to me, this is kind of the easy way, maybe this get started way to create it. Now what this means is you would order 2 separate circuit boards, and they'll both come finished. You don't have to snap anything or file off any rough edges or anything like that. So this is one method. And then let me show you the actual printed circuit boards. This is the control board, right? And I've laid out all the different controls, and you'll see up here I've got the top header. Now what's important, you'll notice that this is upside down or backwards, whatever you want to think of, because this is on the bottom layer, right? You want this header to be on the bottom layer. Another thing that's important is, where is this square? The square is pin number 1. Okay, so on both cases I have pin number 1 on the left, and this is important when you go to create your other your second printed circuit board. Let's take a look at that one. This is going to be the main board, so this has all of the components on it, right? So if we look at the bottom jumper jack, notice that we've got header, we've got the square on the left, just like before. Also, if you hover over it, this is offset 2. When you do this, you want to make sure, of course, that you're using the exact same labels going across. If you swap these around, then of course you're going to have a big problem. So that's one thing you want to be careful with when you're doing this kind of splitting up procedure. All the power stuff goes on the back, on the bottom layer, so that it's facing the back of your Eurorack cabinet, so you can plug into it easily. You know, the way you change things is you just click on them and you change them to the bottom layer. Now when you do change them, they normally flip around, so you may have to rotate it a couple times to get it to the orientation that you want. So just be aware of that as well. I'm going to talk about how I get the positioning of these printed circuit boards so that everything lines up well. If you look, the way I do it is I create one of the boards first. It doesn't really matter which one, but let's say we started with this master board, and I get this header placed. Now this printed circuit board is going to be 20 millimeters wide, and you'll notice it doesn't quite hit. I like to leave a 1 millimeter on either side. That just gives you that little bit of extra room inside your case where you're not butting right up against the next module. So that's a matter of taste. You can go all the way, of course, and I'll explain where you get those dimensions in a moment. But anyways, so we know where that centered. If I center this, I want it to be at 10 millimeters, right? So if I click on this and we look at the X location, let me switch to millimeters here, and let's choose that jumper. Oh, I'm sorry, this is a 30 millimeter wide faceplate, and the printed circuit boards are 28 millimeters wide because I'd like to put that 1 millimeter on each side. So let me clarify that. If you look at the X location, it's at 15 millimeters, so that's perfectly centered left to right. And then same thing if we go up here, I've got this top header centered from left to right. Okay, now let's talk about the location, Y location. Once you get it where you want it, then you want to leave them where they're at, and when you go to your other printed circuit board, now you can match those exact same dimensions. So if I click on this bottom one, it's located 15 in the middle and 11 up from the bottom, right? 11 millimeters up from the bottom. So if we look at this one, it's at 15 and 11 millimeters. So you see how those line up perfectly? that guarantees that when I get my boards from the manufacturer, it's gonna line up and everything's gonna match. Let's discuss how we get these dimensions. Why don't I put this printed circuit board on the origin? Well, the reason is because I want to make the faceplate as well, and I want everything to be lined up. So the easy way to do that is put your printed circuit board in space exactly where it will be in reference to your faceplate, right? If we look at this, let's see. If we look at this, this is in FreeCAD, by the way. I'm going to try to do a quick tutorial on doing your 3D components, which is, like let's say you create that 3-pole double throw switch. We can make a 3D model so that when we do the rendering, it'll show up inside of our render. That'll be down the road. I'll do a short tutorial on that. But anyways, this is FreeCAD. It's available. I just wanted to lay out the board in here so you could see. So the total dimension of a Eurorack module is 128.5 millimeters, which you can get from the Dofer Construction Details webpage. We know that the holes are 3 millimeters from the top, 3 millimeters from the bottom, and the first hole is centered on 7 millimeters from the left side. This is a 6 HP, so it's going to be just one hole on it. Now the other box, the green box here, is 110 millimeters. That's what I've found to be the max that I want to go as far as space. You need to leave space for your rails. Some people recommend 100. I like to squeeze it to 110. I haven't had a problem with that. So if you think about it, 128.5 minus 110 is 18.5. So that means the space from here to here is 9.25 millimeters. So there's 9.25 millimeters here, and there's 9.25 millimeters here, and if you add in that 110, that equals the 128.5. So hopefully that explains where the numbers come from. Let me show you how you do it. You go to Tools, Set Board Outline. In this case, I want that extra millimeter, so I put 1 on the X, and I put 28 millimeters wide. You could also certainly do 0 and 30 if you need those extra 2 millimeters. Now the start Y position is 119.250. So that's up 119.250 from the origin. Remember, that's that 110 plus 9.25. And then the height is only 110 millimeters, so that's why there's a space down here. Hopefully this is making sense. And the reason is you can create your PCB for your face panel using those same numbers, using the same position, except your faceplate is going to start at 0, 0. So your faceplate PCB will go from 0 to 128.5 and across 30 millimeters. And then you can transfer over all of your locations for your holes quite easily. So that's the strategy. So this is strategy 1 for creating a multi-stack PCB. Hopefully that covers that one pretty well. Let me show you the other strategy, which I guess you might call a more conventional strategy. Okay, so remember we left off with our Buchla low-pass gate. This is the basic schematic here. And then let's take a look at this schematic. This is the one that I've modified, okay? What I did is I split off all of the control stuff and I used net labels between them. Okay, I decided to use A and B. So A goes to the control board, right? The PCB with all the controls in it. And then B goes to the master board. Now the reason you have to name these different, CVA and CVB, is because if you don't do that, you're going to have nets that go across your two PCBs in your printed circuit board design. I'm not sure how they would handle that if you don't finish those when you send it up to the manufacturer, so I find this just to be a little easier. So now let's take a look. I've got 4 jacks on this one because I've got a top header that goes to control, the control board top, and then I've got a main top, right? So these headers join together, and you've got the main board and the control board. And you'll notice switch 2A goes to the control board, switch 2B goes to the main board. So I've lined them up and I've made sure that they're consistent across. Now notice I did not use a ground symbol here. Again, that's because when we go to make our printed circuit board, it's going to try to connect these two across the two boards. But I don't want that. So I just made a net called ground A. And then that's going to connect to the ground on the main board. Same thing with the 12 volts. I made a net called 12 VA, and that goes to the bottom control board, and then the header on the bottom main board has the actual 12 volts on it. Now in this case, you'll notice that I did put some components on the control board that are not controls. For example, these resistors, a capacitor. Why did I do that? Well, it just makes it easier to distribute your stuff. On the control board, you're going to have a bunch of empty space in between your pots and all that. So if you pick good places, you can switch out. You can move some of these components from your main board up to your control board, and that can help you with laying out. So let's take a look at the actual project here. So now you'll notice here I've got two sets of control board, or two sets of printed circuit boards. Let's try changing the background, maybe make it a little easier. Right, so we've got our two boards, and this time you'll notice that all of our components are on this big outside. You'll also notice that when I ran the Panelize tool, it did this. It created these remarks here, which are for the PCB company, and you'll see it says V-cut. So they're going to do a V-cut between these two. This is the smallest V-cut they can do, 2 millimeters. So in between these two boards, they're going to run a router with a V bit, right? So that when you go to snap them, they should snap nicely. So how do we get from the schematic to here? Well, let's go ahead and make a new schematic, or a new printed circuit board. So we're going to go here and we're going to do convert schematic to PCB. Oops, I'm on the wrong one. Sorry about that. This is the original one that doesn't have any of the headers on it. Don't save. Where was that? That's the one I want to use. Right. Looks like I changed something on there. I got the star. Let me save it. Oh, I moved a couple labels. All right, so let's convert this schematic to a printed circuit board. So we're doing it from scratch. Now remember, we want our printed circuit board. Normally, this is a 20 millimeter wide. So normally we would want to go from 0 to 20. So we would put 0 and then 20 here in the width. But this one we're going to go to 42. So 42 millimeters wide. We've got the two boards, the two 20 millimeter boards, and then we've got the 2 millimeter V-cut that I explained in the middle. Now remember, the start Y is going to be 119.25, and it's going to be 110 millimeters tall. Everything else is going to be the same. We're going to leave alone, and we hit apply. So now we've got all of our printed circuit board to start with. I'm going to grab everything and just kind of move it out of the way here. Okay, now we want to run the operation to panelize this. So you go to Tools, Panelize. We're going to do a V-cut. Now the number of columns is 2. The column spacing is 2 millimeters, and the row 1. And alright, I just realized I messed up, but I'll show you why. That's what's the beauty of YouTube tutorials. I can show you the mistake I made. So I said it was 42. This is the board outline, and if we go to do Panelize, and we want to say a V-cut, and we want to say 2 columns, right? 1 row, and the column spacing is 2 and the row spacing is 2. We hit apply. See, it panelized the whole 40 millimeter. That's not what I wanted. I wanted 20 and 20. So I messed that up. I'm going to do a Control Z. I'm going to go to Tools, Set Board Outline, and we'll change this to 20 millimeters and hit apply. And then let's try the Panelize here. Tools, Panelize. Again, we're doing a V-cut. We want 2 columns and 2 millimeters between them, and we apply. Now, there we go. Now it added this text in here, and that's just for the PCB factory. And then we've got our printed circuit boards. Now what we can do is take a look. Let's go ahead and let's see what let's change to millimeters and change our snap here. Canvas attributes. Grid size is going to be, let's do 5mm grid size. Okay, so we can see we've got 5mm grid size, so we've got 1, 2, 3, 4. That's 20mm. 1, and then we've got the offset of 2mm, and then we've got the same width there. So it looks good. Now you would want to do your control board on the left, because that's what you want to line up with your printed circuit board. I'm sorry, with your panel. If you put your master board here, your main board, then you wouldn't have location for your pots. They would be over here. So you would want to start placing all your stuff over here onto this one, right? And the reason this one's a little more complicated is you need to figure out which components go on which side, right? So what you could do is you could go back to your schematic and you could label all these. For example, this could be your stuff on your control board could be R1 through whatever, and then the stuff on your main board could be R100 through 110 or whatever. That way, when you go here, you know that anything that's a R1 needs to go on the control board, and then anything that's R100 and up needs to go on the main board. So if you look at our headers here, if we click on them, we can find out this one is the top main. And you can go ahead and change that by doing display prefix no and display name yes. So now it's going to show up that this is the top main board. So I know I need to place this one up here. Okay, this is going to be the bottom control board. This one here is the bottom main, and then we should have one more, which is the top control. So with this one would go up here, the bottom control would go, oops, grab the label, and then bottom main. So in this one you're going to do the same thing, but you got to think a little bit about your math. So we know that we want this centered. Right now it looks like it's centered. We've got the X location is 10mm. That's perfect. Now this one has to be offset because we have this V cut. So we don't want it to be at 20mm, right? The X location, it needs to be add 2 to that. So let's see, we've got 10, 20, and then we've got 30. So 32 would be the center, right? Because we got 30 would be the center if there was no V cut, and 32 is the center with the V cut. So I'm going to go here and change this to 32 right there. So now I've got these guys lined up correctly to where they're going to match. Now remember what I was telling you about the headers. The one on the top needs to be put on the bottom layer. So go ahead and change that to bottom layer. Right? You see how it flipped pin number 1 around? So now you want to rotate that twice. Now if you left it on the top layer and your squares lined up, it would still work. But you would have the silk screen on the top, not on the bottom. So that's the reason that you want to make those line up correctly with this being on the bottom layer of your printed circuit board. Now let's go here. We would do the same thing here. We would just want to make sure that this header is on the bottom layer, and then we're going to rotate it twice to get it back to where the pin number 1 is on the left. And then this one, I'll line it up that way, and I'll just check this. It's already at 32mm centered, so we're good as far as that goes. So the rest of the steps is the same as anything else that we've done previously in the tutorials. You would just lay out everything exactly how you want it, and you would go ahead and create your routing of all your tracks. And remember, you're going to put all of your power stuff on the bottom of the main board, so that's going to go on the bottom layer. Let's take a look real quick. Oh, one thing I wanted to show you, that the 3D rendering doesn't quite work so hot with the panelizing. Right? Oh, so there you can see that I did a test model of that switch using FreeCAD. The only issue I've found so far is that whatever color I make it, the whole thing is that color. Even if I change the colors of the faces, that's not coming through when I bring it into EasyEDA. But that's an example of creating your custom 3D footprint or 3D models to match your components that you make. But everything else you'll see is floating in the air. It doesn't show that second one. Now, panelizing normally in the general sense is normally you would have, let's say you wanted to make 25 sets of one PCB, while you just copy that same exact layout 25 times, and then you panelize, you know, between all those printed circuit boards so you could snap them out. But in this case, we're making two separate circuit boards. We're just doing the panelize function to split them. Now, full disclosure, I have not used this method myself, other than this example. I am going to order this printed circuit board, and I will do a part 3 video and just show you the results and see how it is. What are my concerns? Well, my main concern would be if there's any issue with having different layouts on these two panelized boards. It could be that the printed circuit board company doesn't like that. I'm not 100% sure. So that'll be interesting to find out. And then also, when they do the V bit, the V cut here, how much is going to be left on this edge in between the two boards? So that might be an example where it would be good to shrink your boards a little bit in order to, if you have an edge along here, it won't get in the way of any modules that are next to it. So let's see where we're at. We're almost at 30 minutes. That pretty much concludes this tutorial. As I mentioned, I have plans to show you, at least show you briefly, how to do the 3D models. That's kind of a big topic because I don't want to get into giving tutorials on actual 3D design. There's lots of those out there. I don't think there's a ton of Eurorack EasyEDA tutorials, but there's a lot of 3D design tutorials. So I'm mostly going to just do a quick one. I'll demonstrate how to create that switch in FreeCAD, which is, as the name implies, a free software you can get. And then I'll show you how to bring it into EasyEDA from there. So hopefully you enjoyed this video and it gives you some ideas for how to do your own stacked PCBs. The next step would be creating your panel and then lining up all the holes with your panel, with your controls in the panel, and then setting that and then doing the artwork as I've shown previously, how you can take it out of EasyEDA and bring it into Inkscape, and then that should get you going on your printed circuit board journey. One thing I would say is if you're new to it and you haven't ordered boards before, be prepared for some disappointments. You'll find that you made some mistakes somewhere. Sometimes you can fix it. You can cut a trace and just do a jumper wire or something like that, but that's part of the process. I'm trying to create a product, and I've already done 2 revisions, and I'm getting ready to order the 3rd one. In this case, there weren't any mistakes, but the ergonomic layout, that kind of stuff, or design choices have changed, so I need to order a new set. And hopefully this will be the complete set, but you never know. So anyways, thanks for watching the video. I hope you enjoyed it, and I hope your projects turn out great. Take care.